Today we will dive into 3D animation with JavaScript using Three.js and GSAP. In this workshop, I will teach you the basics of Three.js and how to incorporate GSAP to add extra animations. Now let me give you an overview of this workshop. Today we will go through scenes, cameras, lighting, objects, and material. And all of this will be rendered through the browser. After this, I will show you how to incorporate more animations with GSAP, and finally, we will end the workshop by teaching you how to import 3D models into the browser. So what is Three.js? Three.js is a cross-browser JavaScript library and API. It is used to create and display animated 3D computer graphics in a web browser using WebGL. The source code can be accessed through GitHub, Node.js, and CDN, which is a content delivery network. Or the source files could be downloaded through their website at threejs.org. So let's get started. Alright, so let's begin. First we will get done with the HTML and CSS. So we'll just make those files. So the first file we will need is index.html. Then we will need style.css, and we will need our JavaScript. app.javascript. Now I do have a few extra files and I'll explain what those are later. But first let's go into the HTML file, use the boilerplate and name the title 3D animations, and let us link the style sheet by saying link and CSS, and then we need to link our JavaScript. We do that by script, and then we also have to give the source, which is app.js. Now let us add a few styles, so we don't have to worry about that later. So we'll just keep the box sizing to border box, the padding and margin to 0. Then what we'll do is we will go into the body and give it a width and height of 100 viewport width and a height of 100 viewport height. Then what we'll do is we need a few extra divs for the 3D models, which we will be doing last. So we will just name this scene 1, and then we will have dot scene 2. Now we have these scenes, we can just style them a bit. So we can say dot scene 1, and we can give its position of absolute. Then we can give it starting from the left and a height of 50%, of a height of 100% and a width of 50%. The same thing we can do for scene 2, but what we will do is keep the position to absolute, but we will start from the right side. Then we can give it a height of 100% and a width of 50%. Alright, now we're done with the HTML and CSS, and we can move forward to JavaScript. So how do we import the Three.js library? Well, like I said, we could do it in multiple ways, but for this workshop we will be importing it through our CDN. So the first thing you'll want to do is go on your browser and go to threejs.org, and you will land on this page. Then what you can do is go to the documentation, installation, and scroll down to the CDN. Now what you want to do is copy till @ and then paste that in the file. Now for the version, you want to keep it to 0.129.0. Now this won't work immediately. What you need to do is go into your index.html file, and where you added the JavaScript, you have to give it a type equal to module. Now you'll be able to import things through the CDN properly. Now what's the first thing that we can do is we can make a box. Now the box is going to be the basic version of Three.js. This will help us set all the basic stuff right and help us understand how we could animate this later on. So we need to first set up a scene. So what do is we have a constant and we name that scene, and we set that equal to 3.js. scene. Now to check if this is working, what we can do is type console log and scene. Then what we can do is just run it and go into the console, and as you can see, we have loaded the scene. Now what we can do is we can import a few extra other things, such as the camera. So we have constant camera is equal to new 3 dot perspective camera. And now we're going to have to set this to a few things. First, we have to set the FOV, which is what we're going to use is 35 FOV. Then we're going to have to set the width, and we're going to have to set the aspect ratio, and we do that by saying the window dot inner width divided by the window dot inner height. And finally, we have to set the near and far clipping. For this workshop, we'll be doing 0.1 as the near clipping and 1000 as the far clipping. The near and far clipping just shows us where we need to place our objects before they are clipped out of the scene. Now what we can do is set up our light, gets new 3 dot light, this will be directional light. And now what we need to set is the color of our light. So we want a white light, so we'll keep it as all F, and we also want to select our intensity. So the intensity for this will be 0.5. We don't want it to be too bright. Then what we can do is we can set up our renderer. This is what will take all our scene, our camera, lights, and the object and put them all together. So what we can say is constant renderer is equal to new 3 dot WebGL renderer. Now what we need to do is we need to have our item. So our item, like I said, is going to be a box. So what we do is set up this box, gets new 3 dot box geometry. And then what we need to set is the X, Y, and Z axis for this. So because we want a cube, we will have to have them all same. So we can set it as 1, 1, 1. Alright, now we need to give a material for our box. So what we can say is const material gets new 3 dot mesh basic material. And what we can do in here is set the color. So we can say color is 0x2222f. And then what we need to do is combine all of this using a mesh. So what we do is new 3 dot mesh, and then we need to feed it our box and the material that we're going to be using for it. So we say box and material. Now if you save this and run it, you're going to see that nothing shows up, and that's because we haven't put it in the renderer yet. What we need to do is first set up our camera position, light, the renderer, and the document. So we do that by saying the camera dot position dot set, and what we can do is either put it like this, which gives us the X, Y, and Z, or what we can do is say camera dot position dot C is equal to 5. Then what we need to do is set our light. We have our light and we say dot position dot set 0, 0, 1. Now you can do the same thing for the camera, but it's best to just leave it like this because we won't need to set our X and Y for the light. Now we need to put our renderer size. So what we say is render dot set size set to the Windows inner width and Windows inner height. So we can just copy that here, comma, and paste that. Now what we need to do is set the renderer color. This is the backdrop of our renderer. So if we leave it blank, it will be a black state. So what we can do is just not set it for now. Then what we need to do is select the document dot body dot append child, and then we can say render dot DOM element. This will put our renderer on the browser. Then what we can do is add all of this to the scene. So scene dot add, and then we can add our mesh, which includes the box and the material, and then we also want to add our light. Alright, now what we can do is we can add an animation function which allows us to rotate the box. But first, let's see if we can see our box. Well, as you can see, it's still not showing up, and the reason for that is we still haven't added that to our render. What we can do is say render dot render. We give it our scene and feed it our camera. As you can see, we now have a square on our screen. The thing is, it's a box and the position of our camera doesn't allow us to see what is behind it. So what we can do is we can add an animation that allows us to rotate the box. So we can say its function animate. We're going to have to put the renderer inside, and then what we can say is request animation frame and animate. Then we can say it's mesh dot rotation dot y plus equal to 0.01. And the reason we're putting it so slow is because it is in seconds. So what we can say is animate, and then we can run it. As you can see, now we have a cube that is rotating. As you can see, we have a little bit of jittering on the edges, and the way we can fix that is by calling our renderer. So we say render dot set clear or set pixel ratio, and then we say device pixel ratio. Now when we save that, you can see that we have a much more smoother animation. Alright, now that we're done with adding the cube, what we can do is have a little more fun with this. Now we can add a plane, and we can edit this plane to make it our home landing page. So how do we do that? Well, we're going to have to change a few things. First, we're going to need to change our box into a panel or a pane, and then what we can say is new Three.js dot plane geometry. Now this will take in 4 values. So the first value will be the width, the height, and then we're going to have the width segmentation and the height segmentation. This will come into play in the future when we have to add a little bit more depth to our plane. Now we're also going to have to change our material. So what we need to do is we're going to have to say, we're going to have to remove our color, and then what we can say is side is equal to 3 dot double side. Then what we have is our flat shading, and what we can do is It's flat shading with a capital S. Just remember to have the capital S, and then set that to 3 dot flat shading. And finally we need to have vertex colors. So vertex colors, and then we set that to true, and then we can save that. Now what we need to do is set our mesh or our material. We need to set our mesh to change with our plane and have the same material, because we've already edited that. Now what we can do is we can keep the camera position same. We can add a little bit of light, more extra light, and we can run this and see what happens. As you can see, it hasn't run yet, and we can check why that is, and it says flat shading is not a property of this. So let's check what it is. So what we need to do is, for the material, we need to change it from a mesh basic material into a mesh Fong material, and this should work. Now if we run this, we should see that we have a pane that has disappeared into the background. So what we can do is change the background color by saying render dot set clear color, and then we can set this to white by saying 0 ff, and we can set the intensity to 1. Now you can see that our plane shows up. Alright, and now what we can do is we can move on to the next part, which is adding a little more depth to our plane. Alright, now that we're done with the regular plane, what we can do is we can add a little more extra features to this to make it look more 3D and more realistic. So what we can do is we can first increase the size of our plane to 3, and for it to have 5 segments of the width, 5 segments of the height. Now we can also add a little bit of backlighting by saying the const of backlight is equal to new 3 directional light, and we set it to the same value as the one above. The only thing that will change from this light is its position. So what we can say is here backlight dot position dot set 0, 0, -2. This will position the light behind the object. Now what we need to do is save all our mesh objects into an array, and then we can do that by saying const array gets new or gets mesh dot geometry dot attributes dot position. This saves the position of the mesh of each vertices in the mesh into this array. Then what we need to do is we need to take these vertices and change the z level of it to give it a different one for each of the vertices. So we can do that by having a for loop, and in this for loop we let I equal to 0 and then I less than array dot length, and then we say I plus equal to 3. This will loop through all the every 3 indexes in the array, and we do this because we only want to access the z index, not the x or y. So what we can do now is const of z is equal to array 1 I plus 2, and then we say array I plus 2 is equal to z plus math dot random. Now if you run this, we will be able to see that our mesh has, or looks kind of funny because it has a different z index for each vertex in itself. Now what we need to do is we can increase the size to 10 and add a few extra vertices or segments. Now that we have set the plane, we can just run and check our plane, and as you can see, we have different depths of the vertices. To have a better view, we can just reduce the size of the width and height, save that and check it out. Yeah, now it's showing. Now what we can do is we can add a few extra features. What I will be doing is I will show you how to add a hover over feature that changes the color on hover. So let's get started with that. So first we need to initialize our mouse by saying const mouse, and then in that we set the X to undefined and Y to undefined. Now that we have our mouse, we can set our raycaster, and you say const raycaster gets new 3.raycaster with a capital R. Alright, now what we need to do is we need to set the initial colors along with a few extra other settings. Now what we need to do is have a const array for color. We do that by saying color, and then we have the brackets. Then we have for loop, let I equal to 0, I less than the mesh dot geometry dot attributes dot position dot count, and then I plus plus. Then we need to say color dot push, and then we'll be pushing out a black color, which is the color of our background. Then we need to set our attributes, the geometry attributes, to mesh.geometry.attributes, and then we say color, and then we say new 3.buffer attribute. We give this new float 32 array, and inside that we assign our colors. Alright, now that is done, we need to add to our animation function, we need to add a couple of things. We need to add our normal initial color, which is black, and then we also need to add our hover color. This will be the white color. But before that, we need to import the GSAP module. This will help us with the hover effect. So what we can do is insert the CDN for the GSAP, which I've already copied here, and it will be available in the description. You can just copy and paste that, and then what you can do is go into the app.js, and then inside the animation function we can start working on the hover effect. We can say that the raycaster dot set from camera, we give it the mouse comma camera. Then we need to set our intersection, so we say const intersection is equal to the raycaster dot intersect object. Now what we can do is set our normal and hover colors. So we do that by giving const of normal a few RGB values. So we have R of 0, comma B of 0, B gets 0, and G gets 0. And this is because our background color is black. And then we can just copy this, paste it, and then give it our hover color. Since our hover color is going to be white, we can just set all of these values to 1. Now we can access our GSAP module and say GSAP.to, and then we give it hover, and then we say RG, R, G, and B. And we say normal, assign it to normal.r, and then normal.g and normal.b. Alright, then we need to set our duration to 1, to 1 second, and then on update we need to update the colors. So we can say function is equal to color dot set x intersection of 0 dot face of A gets hover of R. Now we're going to have to repeat this a couple of times, 9 times in total. So we can copy this, paste it, and we have to change a few things. So the X will go to Y, and then X to Z, and our X value will be R, our Y value will be G, and our Z value will be B. Now we have to copy this and paste it twice, and then we can change the face to B, and then finally the last one we can change it to C. Alright, now we need to push these colors by saying color dot needs update equal to true. Alright, we can run the file, and as you can see our pane has loaded up and our hover effect is working. And now what we can do is we can close this part and we can move on to the 3D models. As you can see, I already have a few two files with GLTF 3D models, and we also have a Three.js master zip file. Now what we can do is we can make another JavaScript file. We can name it new app.js, and we can go into our HTML and we can link that file here. What we'll need to do is also comment out the 2 other script files, and now we can work on the new app.js. What we can do from the old one is we can copy the import and paste it. Now the importance of this file is what I will explain right now. We will open this in Explorer, and then we will open up the file in zip. Now what we need to do is from this zip file we need to get the path of where we can get the GLTF loader, and we need to do this because we need to import it as a module. So the GLTF is located in examples, JSM, loaders, and the GLTF loader. So what we need to do is copy this, and we need to import the GLTF. So we'll say GLTF loader, and then we can add our paths. So it's examples /JSM /loaders /GLTF loader, and don't forget to add the .js. Now that we've imported our GLTF loader, we can now import our 3D models into JavaScript and display them on the browser. So to do that, we can have a couple of things. Since we have two files that we are going to display, or two models that we're going to display, we can have two of each variables. We can say let container 1, we can name the second one container 2. Then we need to have two cameras, so we can say let cam 1, let cam 2, let render 1, let render 2. Then we have different scenes, so we have to say let scene 1, let scene 2. Then we have to import our models, so we have let house and then we have let shoe. Now what we do is we can make a function, so we can say function house show, and for now whatever we've learned from our previous app.js, what we need to do is we can use those same settings that we have before. So we can say container 1 is equal to document dot query selector, so query selector. And now we already had a few scenes prepared, so what we can do is we can select this as dot scene 1, and then we can say scene 1 dot, or scene 1 gets new 3 dot scene. Alright, then what we can do is we can set our FOV, our near clipping, far clipping, and aspect ratio. So what we need to do is set cam 1 equal to new 3 dot perspective camera, and then we can set our FOV to 25, comma container, so we can say it's container 1 dot client width, and then divided by container 1 dot client height. Then our near clipping, which is 0.1, and 1000, which is our far clipping. Save that and we can continue. Now we need to set our camera position, so we can say cam1 dot position dot set 0, 3, 30, and then we can set our ambient light, so const ambient equals new 3 dot ambient light, and then we can give that a hex value of 40, 40, and 40 along with the intensity. Then we can have a light, new 3 dot directional light, and we can put this to white, and we can set our intensity to 2. Now we can set our light position to position dot set, and then we can set it at 50, 50, 100. finally we have to add our scene elements dot add, and we can add ambient along with the light. Now that we've done that, as you know, we have to now add our renderer. So our renderer will be render 1 gets new 3 dot WebGL renderer, and now we can also set a few aspects of our WebGL renderer, such as the anti-aliasing. Alias is set to true, along with alpha equal to true. This will just ensure that the rendering is smooth. Then we can set our size, and then we can keep it the same as our aspect ratio. Width, and then we can name this height. Finally, we can set our pixel ratios to ensure that there is no jittering on the edges of the models. So render 1 dot set pixel ratio set to device pixel ratio. Alright, the last thing that we need to do is import our model. So all we have to do is say let loader is equal to new gltf loader, and then we give loader dot load, and then now we have to give the path. So dot slash house, because it's in the root folder, and then we need to select the scene from it, dot gltf. Then we need to mention that our function that we're going to use is gltf, and then scene 1 dot add the gltf dot scene. Now what we can say is house, we get the gltf dot scene dot children, and we select the first one, which is in the first index, and then we can call our animate function, which we will set up in a second. Now what we can do is we can save all of this and copy this function and paste it again, and then we can change this to shoes, shoe, and we need to select scene 2. Just make sure we have to rename all our variables, otherwise they will overlap with each other, and we do not want that to happen. So we set everything from its original to 2. So we have renderer 2, renderer 2, and renderer 2. Now we need to change this house into shoe, and we also need to change our path, change our container, and that should be it. Now what we need to do is we need to have a function that loads this. So we can have a function called animate 1, and then we say request animation frame of animate 1. Now we take our renderer so render1 dot render, and then we give scene 1 and cam 1. What we can also do is we can add rotation, so we can say house dot rotation dot z. We can do plus equal to 0.005. Perfect. Now we can copy this and paste it again. Just need to ensure that we change this to animate 2 and change house to shoe and the render from 1 to 2, and same with the scene and the camera. Alright, after adding the animation functions, we need to now call them in the main functions. So in the first function we can say animate 1, and then for the second function we can call animate 2. Now we also need to add these to the containers. We need to add the containers to the DOM element. So if you remember, it would be container 1 dot append child, and then we say render 1 dot DOM element. Save that. We can copy it and we can paste that for the second function. Just remember to rename them. And then finally what we can do is now call the main functions, which is house show and shoe show. Save it and we should now run it, and as you can see, our 3D models are loaded. Now you can see that our shoe is slightly lower, and that's an easy fix. So all you can do is change the camera position. So instead of 3 we can make it 1, or we can make it 6, and as you can see, the direction of our shoe changes. And that will conclude our workshop. Thank you. So that's it for today's workshop. Today we managed to cover a few things with Three.js, such as the scene, camera, lighting, objects and material. We also managed to render all of this on the browser while using GSAP for hover animations. We also managed to import a 3D models into the browser. If you enjoyed, consider hitting the like and subscribe button, and to stay up to date with our content, you can follow us on our social media. Thank you.